morning, my YouTube viewers. This particular video, we're going to be talking about logistic regression. And logistic regression is a part of statistics, but it's also a part of machine learning. So if you've studied machine learning, you may be familiar with logistic regression already. But logistic regression was part of statistics before it was part of machine learning. And the reason why is because statistics is a much older science than machine learning is. So logistic regression is used for classification problems where the dependent variable is binary. So you have like success, failure, yes, no, true, false, on, off. That is how logistic regression is used. So we're going to demonstrate logistic regression by writing a program in Python to do that. And so in order to write the program, what we're going to have to do is we're going to have to import some libraries to help us to execute the program. So the first thing that we want to do is we want to import NumPy as NP, which is a numeric library. And then we want to import matplotlib.pyplot as PLT, which is a visualization library. And finally, from sklearn.linearmodel, we want to import logistic regression, which is the algorithm that we're going to use to demonstrate logistic regression. So we have an example of our studied versus pass-fail outcome. So your independent variable is your hour studied, and your dependent variable is your pass-fail. So you've got your hours studied is a NumPy array from 1 to 10 that has been reshaped so it can be used with the sklearn model. And your dependent variable is pass-fail, and it's an NP array of zeros and ones. So 1 is a pass and 0 is a fail. So your hour studied is your x variable and your pass-fail is your y variable. And then now we're going to define our model. So our model equals logistic regression dot brackets dot fit brackets hour studied comma pass fail. And then we're going to generate the probabilities. The x values equals np.linspace brackets 0, 12, 100. And we're going to reshape that to -1, 1. And then our predicted probabilities equals model.predict proba x values brackets colon 1. And then so that's going to give you probability of passing. So we print the regression coefficients. So we print the coefficient slope, we print the intercept, and we print the score of the prediction. And the coefficient slope is 1.18, the intercept is -5.31, and it gives you a score of 100%. So now what we're going to do is we're going to visualize the data. So plt.figure brackets fig size equals 6, 4. We're going to create a scatter plot of the data. plt.scatter bracket hours studied, comma, pass fail, comma, color equals blue, comma, label equals data points. We're going to plot the logistic regression curve. plt.plot brackets x values, comma, predicted probabilities, comma, color equals red, comma, label equals logistic regression curve. And now we're going to add labels, title, and a legend to the chart. The title is logistic regression hours studied versus pass fail. X label is hours studied. Y label is probability of passing. You get a legend and you get a grid, and we're going to show it. And so now you can see that we've got our chart logistic regression, hours studied versus pass-fail. And then so you've got on the X variable, you've got hours studied, and on the Y axis, you've got probability of passing. And so you can see that the blue dots are your data points, and your red line is your regression curve. So that concludes this video. The next series of video we're going to have is going to be time series analysis. So I hope you decide to watch the next videos as well.